Okay, so hello and welcome back. So the next question is using the section formula. So you want to using the section formula prove that the 3 points that the 3 points -4, 6, 10, -4, 6, 10, 2, 4, and 6, 2, 4, 6, and 14, 0, -2, 14, 0, -2 are collinear. So basically you know that if you can show that some point, basically a point divides a line segment in some ratio, that means that, well, of course the points have to be first collinear and then basically the let me say it this way. If you can say that we can use the section formula to prove that, for example, 3 points are collinear, and the way that we can use it, we can basically show that, for example, some point divides some line segment internally or externally in some ratio, and that means that the 3 points are collinear. And the reason why we can do that is that basically, for example, in this kind of situation, if you want to know whether you are logically allowed to basically use the section formula to prove that, for example, 3 points are collinear, you need to understand basically where the section formula comes from. Now the section formula comes from and that you can know basically based on how the section formula has been proved, or how it's been derived. Basically, now the section formula comes from basically we have, for example, in two-dimensional space, let's say that we have, for example, okay, so let me show you something over here. For example, that's how we use the section formula. That's how we So basically what we, for example, let's say in this case, what we had basically these 2 points A and B with coordinates x1, y1 and x2, y2, and we had some point C, and of course that you know that 2 points are always collinear. Now if 2 points are always on a plane, are always collinear, if there is a third point and then and then we went through some algebra over here, and we derived some formula over here, which was called the section formula for example, in the case of a point basically dividing a line externally. Now what that means is that if a third point basically, if there is a third point that satisfies the section formula, that means that point has to be collinear with the first 2 points, based on how basically the section formula has been derived here. So that's how you know that you are logically allowed to use the section formula in order to prove that, for example, in order to prove that 3 points are collinear, based on how you have derived the section formula, for example, from here. So now what we can do, I mean, this is basically where the importance of deriving these formulas and these equations and these everything that we do in mathematics, the derivation is important. If you understand the process of the derivation, then of course you will understand the process, and then you will know where exactly you're allowed to use that formula, for example, that you get as a result of that derivation, where exactly you're allowed to use it logically and where not, basically. So that's basically the importance of deriving things yourself and understanding the process of the derivation of some result or some formula or some equation or anything like that. So then over here, if I call these points, for example, A, B, and C, if I call these points A, B, and C, so using the section for you want to use the section form to prove that the 3 points are collinear. Now, if let's suppose that, for example, there is the way that this problem has been solved in the book, it's actually an interesting way, meaning that they have assumed that let's assume that there is some point, for example, they've called it P, some point P, that divides the line segment AB in the ratio, for example, K to 1. In the ratio K to 1. Okay? Then the coordinates of the point P would be, so the coordinates of the point P would be, so we said that basically the coordinates of a point dividing a line segment in the ratio, for example, m to n, was, for example, if I call it, for example, P, that would be basically m times x2 in 3-dimensional space, m times x2 plus n times x1 over m plus n, and basically m times y2 plus n times y1 over m plus n, and m times z2 plus n times z1 over m plus n. Okay, and then now this is basically provided that the ratio is m to n. Now if I take the ratio as, if we take the ratio as k to 1, we will have basically the coordinates of the point P will be basically k times x2 plus x1 over k plus 1, and the y coordinate would be k times y2 plus k plus y1 over k plus 1, and the z coordinate would be k times z2 plus z1 over k plus 1. So that this formula you can use, I mean these coordinates you can use in order to find the coordinates of the point P that divides this line segment AB in the ratio k to 1. So then what I'm going to do is that I'm going to write the coordinates of the point P as basically k times, over here you have, take x2 as 2, so k times 2 plus x1, which is equal to negative 4 over k plus 1, and the y coordinate would be k times y2, which is basically 4, so 4 times k plus y1, which is equal to 6 over k plus 1, and k times z2 would be k 6 times k plus z1, which is basically positive 10 over k plus 1. So all I need is to rewrite this. This is 2k minus 4. This is 2k minus 4. 2k minus 4 over k plus 1. And so these are the coordinates of the point P. Now, now what I can do over here now is that the point C, I wanted to know if this point was collinear with these 2 points, 14, 0, negative 2. 14, 0, negative 2 was basically the coordinates of the point C. Now if I equate 14, for example, to this coordinate over here, I'll get 2k minus 4 over k plus 1 is equal to 14, which means that 14k plus 14 is equal to 2k minus 4, and which means that 14k minus 2k is equal to negative 4, negative 14. So that means that basically 12k is equal to negative 18, and what that means is that divide by 6 you will get 2 here, divide by 6 you will get 3 here. So that means that k is equal to negative 3 halves. So k is equal to negative 3 halves here. Now, if I use the same ratio, if I use the same k to check basically for these two coordinates as well, and if I get the same coordinates over here, then that means that this point C is actually collinear with the other 2 points. So I'm going to use basically if k is equal to negative 3 halves, then 4k plus 6 over k plus 1 is equal to 4 times negative 3 halves plus 6 over negative 3 halves over negative 3 halves plus 1. Now this is 2. So that's basically 2 times negative 3 is negative 6 plus 6 is equal to 0. 0 divided by something, which is equal to 0. And that is equal to this 0 over here. Now again, if k is equal to negative 3 halves, 6k plus 10, 6k plus 10 over k plus 1 is equal to 6 times negative 3 halves plus 10 over k over negative 3 halves plus 1. Negative 3 halves plus 1. Which is equal to basically 3, that is negative 9 plus 10 over, this is, well, negative 3 halves plus 1 would be 2 halves, which is negative 1 half. So that's negative 1 half, that is basically 1 over negative 1 halves, which is equal to negative 2, which is the same number over here. So that means that basically all the coordinates of this point, that means that this point is actually collinear with the other 2 points, which means that the 3 points are collinear. So, and if I want to say it in a better way, or I can say that therefore C with those coordinates 14, 0, negative 2, 14, 0, negative 2 is a point that divides AB externally, that divides AB externally, and it's external because your k is a negative number, I suppose. It is external because your k is a negative number, because then basically I'll tell you more about this. Externally in the ratio 3 to 2. In the ratio 3 to 2, and is same as P, and is the same as P, hence A, B, and C are collinear. Hence A, B, and C are collinear. So this is the kind of statement that contains no ambiguity. When you say something, it has to be clear, concise, without any ambiguities, and this is the kind of statement that contains no ambiguity. Now about this point that says externally, this is also important and you need to pay attention to it. So I used the formula that we used for internal basically division, and I set basically the ratio as k to 1. I set the ratio as k to 1, right? I used this formula as basically the coordinates of P, for example. I said that it's k times x2 plus x1 over k plus 1, and then the y coordinate we got it as k times y2 plus y1 over k plus 1, and then we got k times z2 plus z1 over k plus 1, and over here we got the ratio as k to 1. And then when we calculated the ratio, the ratio turned out to be k to 1 was negative 3 to 2. Was negative 3 to 2. So what that means is that your k is basically a negative number, because 1 cannot be a negative number. And k is basically originally we got k by setting basically m to n. The ratio was originally m to n in the formula that we had, and we set the basically we used then we m to n, I can write it as m by n to 1, right? I can write it as m to n to 1. And then if you take m to n as k, this becomes k to 1. So now when your k is a negative number, what that means is when your k is equal to negative 3 halves, what that means is that m by n is equal to negative 3 halves. And so one of these has to be a negative number. One of these has to be a negative number. And you can, of course, you can imagine that the negative number is basically your n. And that's basically by meaning that m is equal to positive 3 and n is equal to negative 2. And when your n is a negative number, is a negative number, that becomes exactly the situation when a point divides a line externally. A point dividing a line segment externally, which was basically for which we got this formula. Originally the coordinates of the points were basically m times x2 plus n times x1 over m plus n. This was the x coordinate. Then the y coordinate was m times y2 plus n times y1 over m plus n. And then we had m times z2 plus n times z1 over m plus n. We had this for the coordinates of the point dividing the line internally. This was internal. And then when we derived the coordinates of the point dividing the line externally, we got this formula, these coordinates, as basically we said that every n becomes a negative n, meaning that the coordinates became mx2, mx sub 2 minus nx sub 1 over m minus n, and my sub 2 minus ny1 over m minus n, and then we had m z2 plus minus nz1 over m minus n. And you can see that over here your n is negative. Well, your n is negative because n is originally basically n is originally a ratio, and a ratio is well, m to n is basically in this context where we used it, where we said that m to n, m and n was basically the ratio of two distances. And so based on that, I think I can say that m and n are both positive. So when you write negative n becomes a negative number. And so over here, you see that you get your n as a negative number. And so based on that, you can say that the point that we found in the previous exercise, you can say that that point, based on the negative ratio, you can say that the point is dividing the line segment AB externally. So that's important. You need to pay attention to that. So that is that. That is that. So there is two more questions here. Let's do these questions as well, and we will finish this part. Okay, so the next question that we have is actually some interesting question about a triangle's, basically a triangle's so about the triangle centroid. So first, before we go to the example, we'll have to talk a little bit about the triangle's centroid and something else called the median. So there is centroid and median of a triangle. Now, if you have a triangle over here, any triangle really, if you have this triangle over here, the median of this triangle, basically your triangle will have 3 medians, meaning that from this vertex, if you connect this vertex to the midpoint of this side, it will be your median. If I call this ABC, for example, E, and this midpoint I call it F, and this midpoint I call it G, and if all of these are midpoints, then AE is one median. Then this is another median. This length over here, or this line segment over here, is another median, and this is another median. Now you can see that all the 3 medians meet at one point inside the triangle, and this point is called the centroid of the triangle. The centroid of the triangle. And these are one of the points of concurrency of the triangle. This centroid is called one of the points of concurrency of triangles. So the points of concurrency of triangles, there are different types of points called, and they are basically, they are called, all together they're called the points of concurrency of a triangle, meaning that, for example, depending on something that you do with the triangle, for example, you draw the medians of a triangle, and then there is this point where all the medians meet at one point. That point is called the centroid. And since all of these points basically all of these lines have intersected at one point, this is one point of the concurrency of the triangle. There are other points of concurrency of triangles. I'm not really, at least not readily very familiar with them. But this is one of the points of the concurrency of triangles. There are other points of concurrency of triangles as well. And so now there are some facts over here that we need to know about these, about the centroid. So it is formed by the intersection of the medians, as you can see over here. And again, one of the points of the concurrency of triangles, and it is always located inside the triangle. The centroid is always located inside the triangle. It's never located outside the triangle. There are some points of concurrency that in some cases are actually depending on the configuration of the angles of your triangles, will be located outside of the triangle, but this point seems to be located always inside the triangle. And the one which is important here is that the centroid, the centroid point, so the centroid divides each median in a ratio of 2 to 1. In a ratio of 2 to 1. And this is the point which is important here for us right now, since we are basically working with the section formula. In other words, the centroid will always be 2/3 of the way along any given median. So this is some I would call it some fun fact about basically the centroid and the medians. In other words, the centroid will always be will always be 2/3 of the way along any given median. 2/3 of the way along any given median. So that's basically that. So this ratio is important. Either you could say 2 to 1, or basically you can say 2/3 of the way along any median. So now, using this, basically we need to solve a problem, and the problem is we want to find the coordinates of the centroid of the triangle. We want to find the coordinates of the centroid of the triangle whose vertices are x1, y1, z1, x2, y2, z2, and x3, y3, z3. So the vertices of your triangle are these. Now, as the solution, always please try to be clear about your thoughts and clear about the logic that you use and clear about your notation and everything. That's important, very important, at least in mathematics. In other places, of course, it's always beneficial to be clear. But at least in mathematics, it's not only important but essential to be clear about your thoughts, about the logic that you use, and about your notation, about your senses, and so on and so forth. So as the solution, you can say that let ABC be the triangle. Be the triangle. Let the coordinates of the vertices, let the coordinates of the vertices ABC be 1, 2, and 3. I call this basically 1, I call this 2, and I call this 3, respectively. Let D be the midpoint of BC. Let D be the midpoint of BC. Hence the coordinates of DR, hence the coordinates of DR. So as a diagram, you can imagine that you have this triangle over here, and this is point A, and this is point B, and this is point C. D is the midpoint of BC. The coordinates of this point is 1. The coordinates of this point is 2. The coordinates of this point is 3. And so the coordinates of D are the midpoint of BC, would be basically x1 plus x2 plus x3. I'm sorry, that would be x1 plus, the coordinates of D would be B and C, so these 2 points. So then you would have x2 plus x3 divided by 2, the midpoint formula, z2 plus, I'm sorry, y2 plus y3, y2 plus y3 divided by 2, and z2 plus z3 divided by 2. So these are the coordinates of the point D. Now, if basically now you can say that let G be the centroid of the triangle. And based on what we said before about triangles over here, therefore it divides the median AD. So you have this median AD over here. Therefore it divides the median AD in the ratio 2 to 1. In the ratio 2 to 1. Hence the coordinates of GR, hence the coordinates of G are, so the coordinates of G would be, basically G is a point that divides AD internally in the ratio 2 to 1. Now your A is basically, your point A is, this is the coordinates of point D, and the coordinates of point A is x1, y1, and z1, and the ratio is 2 to 1 internally. The formula that I need to use here is basically the coordinates of G are basically m times, so I take this as point, for example, as I take this as point 1, for example, I take this as point 1, I take this coordinate, this point as point 1, and this as point 2. So then, so I take this as point 1, and I take this as point 2. What I mean by that is that basically in the formula I have m times, for example, m times x1, m times x2 plus, for example, n times x1 divided by 2 divided by m plus n. And so x1 has to come from point 1 and x2 has to come from point 2, and then in the same way I have my2 plus ny1 divided by m plus n, and so then y1 comes from point 1 and y2 comes from point 2, and so on and so forth. So from now on, whenever I say, I call this point 1 and point 2, so you know what I mean by that. So the coordinates of this point G would be basically m times x2 plus n times x1 over m plus n, and the y coordinate would be m times y2 plus n times y1 over m plus n, and the z coordinate would be m times z2 plus n times z1 over m plus n. And so then the coordinates of the point G would be m times x2. So so I take this as, I take this as point 2 and I take this as point 1. So now m times x2 would be basically your m is equal to 2 and your n is equal to 1. So that's 2 times, that is 2 times, so that is x2 plus x3 divided by 2 times 2 plus n times x1. N is equal to 1 and x1 is basically x1 divided by m plus n, and m plus n is equal to 3. The y coordinate is m times y2, so m is equal to 2 and y2 is equal to this coordinate over here. So you have y2 plus y3 over 2 times 2 plus n times n1. N is equal to 1 and y1 is equal to basically y1 over here plus y1. And then over here you have m plus n, which is equal to 3. And the z coordinate of this point is basically 2 m times z2, 2 times this thing over here, 2 times z2 plus z3 over 2 plus n times z1, so that would be plus z1 over m plus n, which is equal to 3, and that is equal to, so you can cancel these out and cancel these out and cancel these out, and you will have x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3, and z1 plus z2 plus z3 over 3. And this is the coordinates, and these are the coordinates of the centroid of a triangle with vertices x1, y1, z1, x2, y2, z2, and x3, y3, z3. That is that.